Hey everybody, just a quick little video to get you some solutions to the similar triangles quiz here. Just two questions. One's the mirror case and one is the shadow case. We'll do the mirror case first. So you got some measures in here. AE is 4, EB is 5. So this is 4. This is 5. Sorry about the scale. It's not drawn very well to scale up here. And BD is 8. And then I want to know what this guy is. So this is pretty much the same thing we were doing with the tree outside. I've marked some angles equal. Those are both 90. These are both equal. That forces the triangles to be similar, because that means by definition of, well, not by definition, but by the fact that triangles have 180 degrees in them, all the sides are equal, or all the angles, all the angles are equal, so the sides are proportional. Sorry, a little tired today. So then, what you know is you have proportionality amongst the sides. And it depends on how you decided to write it. There's a couple different ways you could write the similarities. I don't know what exactly you guys did. Some people may have gone in the triangle 4:5. Now you've got to pull the corresponding sides from the other triangle. 4:5. 4 is the side between the double ring angle and the 90. Double ring angle and 90, you'd have to go X here. 5 is 90 and single. 90 and single would be 8. So some people are going to write it that way. Some people might write 4 is to X as 5 is to 8. That's the same equation, just in slightly different form. But it can be reduced to the same equation, therefore it's essentially the same equation. So we'll just go ahead and solve this one. This one, it seems like you guys, like me, like to do cross multiplication. I think it's easier just to multiply by 8, because it gets rid of the 8 in the denominator. Then you have 8 times 4/5 is what you're looking for. This is 32/5, which is a totally acceptable answer. If you wanted to knock that down to a decimal, 6.4, I think. 6.4, yeah. 5 into 32 goes 6, remainder of 2, 2/5 is 0.4. 6.4 or 32/5, either one's fine. So there's your first one. Your second triangle over here is the shadow case, like we said. And you're going to have the two 90s here. The unlabeled same angle is going to be this guy. You basically, and this one is interesting. You've got two triangles. Let's get some color going here. You've got two triangles. You've got the big one, and you've got the little one. And the trick with this one, with getting the correct proportional sides, you might actually want to pull the triangles apart. So here's the big one, and here's the little one. And if you pull them apart like that, you can assume those are, I don't think I mentioned that they're perpendicular, but you can assume they are. You can see that this little angle tucked in here is in both tips of both triangles, which forces the last angles to be equal to, which means you've got yourself some similar triangles here. Then it's just a matter of pulling the measures off of the quiz itself. It looks like the vertical is 6, BC is, these are both 6, this is 6, this to here is 6, this is 3. Now, so that's up here actually, 6, this is 6, this is 3, 6 goes from here to here. What you're looking for, I believe, is CD. Yeah, you're looking for this piece right here. Well, that goes from here to here. So if you bring the pink triangle down to here, this whole thing is 6 plus x. It's 6 and then x more. Okay? This guy here goes out to x. It goes out to x. So, anyway, you now have the correct, you have sides, if you will, to actually get to a proportion that you had over here. So a proportion you could use is 6 is to 6 plus x, as 3 is to x. There you go. 6 is to 6 plus x, as 3 is to x. At this point, you solve it any way you want to. Cross multiplication means extremes, isolating x, however you're going to do it. The way I like to think about this is, again, this is going way, way back, probably in your math past. I like to think about what it means for fractions to be equal, right? 6 going to 3 from a fractional, which is division, which is the same level of order of operations as multiplication. 6 going to 3. 3 is exactly half of 6. That means 6 is twice 3. Well, that means the same proportionality has to exist here. 6 plus x going to x. This is exactly half of this. which means to get from here back to there, you have to double it. So essentially, you can just look at this part and say, well, that means 6 plus x has to be 2x, which means if you bring the x over, you end up with x equals 6. And that's what it is. This little piece here is 6. This is called a midpoint of this side of the triangle, 6 and 6. And the reason is because this whole side is 12, this is 6. Each of the sides of this little triangle have to be double the sides of this little triangle. So there you go. You've got yourself 6, 12, 3, and 6, which means proportionality, 1/2, 1/2. So I hope that got you some solutions that you needed, and we'll catch you on the flip side.